Hey, we're here at go-to-math.com. Click on the first derivative test, and I believe we're doing 11-2. Alright, find our relative minimum maximum points. We got the function. I'm going to write that down. So you can kind of see here this little different graph than what we've been used to, that our minimum is occurring right here at an endpoint. Alright, so let's go ahead and write that down and move on over to the whiteboard. Okay, so we had h of x is equal to, now it was the square root, but we're going to go ahead and write it in exponential form. So we have x minus 5 raised to the half, not to the third, and then plus 3. I was getting ahead of myself, I guess. So let's take the derivative. So we have h prime of x is equal to, bring the half out front, x minus 5, subtract 1, so we have a negative a half, and the derivative of 3 is 0. Okay, now let's go ahead and rewrite this with positive exponents. I always get that equal sign kind of off there, and we want to set that equal to 0. Okay, set that equal to 0. Now, what makes the numerator 0? Well, there's nothing we can plug in to get the numerator to be 0, but let's look down here. It looks like our critical number is occurring at 5. It's occurring at 5, okay? So now what we'll want to do is put 5 on the number line. Now, of course, we look up here, is 5 in the domain of h of x? And yes, it is, right? So, okay, that qualifies that to be one of the qualifications anyway, to be a critical number, that h must be defined at c. Alright, so now what we're going to do is test where this thing is increasing and decreasing. Now if we look at a number that's less than 5, what we're going to end up here is with a negative, okay? And then of course we've got raised to the half power, and so the domain actually of this function, if we were looking at the domain, I'll write that right here. The domain is actually 5. It actually includes 5, so we're going to put a bracket here to infinity. Okay, so this is the interval that we're in. All right, 5 to infinity. We put a bracket here because we can use 5, but there's nothing to the left of 5 that we can use for a test point, as you can see, and we can't plug 5 into the derivative because we end up getting 0 in the denominator. So as you can see, we'll have to use only numbers to the right of 5, like for example 6. We'll use 6 as a test point. Okay, 6 is a test point. And so let's find h prime of 6. And when we do that, all we care about if it's negative or positive. We plug 6 in the denominator here, and of course we get 1, and the square root of 1 is 1. So we end up with a half actually. I guess I'll go ahead and write that. So that's a positive number, and that means that the graph is increasing from 5 on. It's increasing. So as you can see, this must be a minimum here, right? It must be a minimum, okay? And all right, so let's write that. So the minimum is occurring at 5. Now this is a point, this is not an interval here. At 5 comma, of course, we would plug 5 in. Up here we get 0, and so 3. 5, 3. That's where the minimum is actually occurring. Alright, and let's move over. Let's see, 1, 2, 3, 4, 5. 1, 2, 3, and that looks like that's about right. Okay. So one other note, it's increasing from 5 to infinity. That's something else that I don't know if I've got this problem or not on the increasing decreasing earlier problems, but anyway, it's definitely one to talk about. Alright, so we got a relative min at 5, 3. Okay, so come on over to Go To Math, practice that, and maybe I'll talk with you there. Bye.